Everyone, and thank you for joining. My name is Tracy Cook, and I'm the online media manager for ModernAnalyst.com, the premier community of business analysts. I'd like to welcome you to today's webinar entitled The Thoughtless Design of Everyday Things. Today's featured speaker is Karl Wiegers, PhD, Principal Consultant at Process Impact. Karl Wiegers is the author of numerous books on software development, project management, consulting, and other topics. Today's webinar will last approximately 60 minutes, including the question and answer session at the end. So please be sure to submit your questions in advance using the questions feature of the GoToWebinar software. I'd also like to say thank you to Northwestern University Data Science for sponsoring today's event. If you've ever thought about a career in data science analytics, check out the online Masters in Data Science program at Northwestern University. You'll learn from experienced faculty who are thought leaders in the field and build the technical, analytical, and managerial skills needed for a successful career in data science. Earn your Northwestern master's degree entirely online and advance your career in data science. To find out more, please visit sps.northwestern.edu/data. You can also download their handout from the handout section of the GoToWebinar control panel. And with that, thank you, Karl. Please begin.
Thank you very much, Tracy, and welcome everybody. Greetings from sunny and about to be extremely hot Portland, Oregon. I'm going to turn off my camera here just so that we can focus on the slides. So I don't know about you, but I encounter a lot of products that seem to be designed by someone who apparently has never used a product of that kind before, which is very annoying. I run into software applications, websites, and physical products like cars and household items all the time that just make me wonder what the designer was thinking. Now, sometimes we find we might have problems trying to figure out how to use some particular product. And sometimes that makes you feel dumb, like, why can't I get this? I must not know what's going on. But usually it's not our fault. A lot of the time, a product is hard to use because it's not thoughtfully designed. So you can feel better about yourself if you've ever had that experience. So I wrote this book, The Thoughtless Design of Everyday Things, to share some of my experiences with these kinds of products and to see what we can learn from them about doing better product design. So I'm not just going to gripe about things. That's easy. We do that all the time, and it's kind of fun and to vent about all these people who design products that we don't like, and also to gloat about people who do. You know, we sometimes encounter products that are very nice. But what I'm going to do today is see what we can learn from that. I'm going to begin with a definition of what I mean by thoughtless design and describe 3 reasons why design is a hard problem. I don't mean to suggest that it's not. Now, as I was writing this book, I found I could group all the examples I'd collected into some categories and learn some things from that. I identified 9 fundamental principles of good design that I look for in products. And I've got more than 160 examples in the book of products that don't conform to those design principles. And that's what I mean by thoughtless. And I've also got, for many of them, suggestions of how to improve the designs, often in just small but useful ways. So today I'll show you quite a few examples of these thoughtlessly designed products. But in the book, I also describe almost 50 examples of particularly well-designed products, and I'll show you some of those today as well. But you know, I don't think it should be a pleasant surprise when we encounter a well-designed product. You know, we've probably had that experience. You're using something and you say, wow, this is really nicely done. But I don't think that should be a surprise. I think it should be the norm. And so my point here is to try to help steer people towards the ability to have thoughtful design much more of the time than thoughtless design. So along the way here, I also identified a bunch of design lessons. And today I'll share 19 of my 70 design lessons with you that I extracted from studying these various products. And finally, I'll wrap up by quickly sharing with you some good practices for usage-centered design, which I think is the best approach to building usable products of any kind. So what do I mean by thoughtless design? Now, I have a nice blue jacket, sort of like this one, that's well designed overall, but it has one peculiar thoughtless feature. There's an inside pocket that's 5 inches or so wide, which is a nice size for holding a phone, a museum brochure, or maybe some sunglasses. But for some reason, the The jacket designer sewed a big seam down the middle of that pocket, which splits it into two much smaller and therefore less useful pockets. I just don't understand why someone would decide to do that. What customer said, oh, this 5-inch wide pocket is way too big. Why don't you make two small pockets instead? I don't think anybody said that. They just made that design decision at some point, and it drives me nuts because that pocket's basically useless. You know, I can put a little granola bar or a couple of pens in them, and that's it. So when I talk about something that's thoughtlessly designed, I'm thinking of products that violate one or more of my 9 design principles. And the sad thing is that many of these products could have been designed better with, I think, little additional effort, just some more careful thinking and maybe some better customer engagement. So let me define some terms that I'll use here. A product or feature is obvious if its presence and usage are readily apparent without anyone having to explain it to you. A product is intuitive if you can make a good guess at how to use it based on its similarity to other products or from other cultural or contextual clues. You don't need to consciously think about how to use it or refer to a manual, you just use it. And a product or feature is easy to use if the user can successfully perform a task with minimal effort and assistance. So you will see these kinds of terms showing up from time to time as we go along here. So why aren't all products thoughtfully designed? It's worth thinking about 3 reasons why I think product design is not easy. It's a hard problem. And the first problem arises because designs are based on requirements. And we all know how many problems people encounter trying to develop an understanding of requirements for any project. And here's a picture of a very early BA writing one of the very first requirement specifications. Okay, I lied, it's really Charles Dickens, but it kind of looks like a BA, I guess. So let's think about why people can go wrong on requirements. And I suspect many of you are analysts, and so you've encountered some of these things yourselves. Maybe the requirements are incomplete, or they're inaccurate, or we have information in there that's obsolete and doesn't lead to suitable design. Sometimes we interact with the wrong people. You know, we're all doing the best job we can. We think we're doing the right things, but sometimes we end up having to work with the wrong people, and we get requirements that lead us to zig rather than zag. I've been doing requirements work and business analysis and training for 30 or 35 years, and the single biggest complaint that I've heard from my clients is our customers don't tell us what they need, they give us solutions. And a lot of times those solutions, while maybe superficially seem okay, are suboptimal in some way. A lot of design focuses on building in certain features into your product, but I think it's much better to focus on usage, what people have to do with it, and then come up with the features from that perspective. Sometimes we focus on the functionality and we overlook the non-functional requirements, quality-related requirements that help us make a product that we really enjoy using and helps us do what we need to do. Or even if we get the right information, maybe it's not recorded well or accurately or thoroughly and communicated to the people that need to do that information, need to use that information to get their job done. So it's important that we record requirements in a way that's clear for the audiences who have to use them. So if we don't do a great job on requirements, then we're going to lead designers in the wrong direction. The second reason is that we have a lot of stakeholders. Perfect design solutions are unattainable. Any solution is always a compromise. So designers need to try to please a lot of stakeholders who can have conflicting interests and objectives. And here I've shown some of the kinds of stakeholders that we typically run into, both for software and for physical products. So one source of tension in the design process is trying to satisfy the complete set of requirements and constraints that these stakeholders present. So for example, certain product characteristics might make it easier to install or service some product, but maybe those same characteristics are inconvenient for users. So we have these conflicting stakeholders. Or maybe a manufacturer likes a design that's easy and cheap to produce, but customers won't be very happy if that makes the product less durable. And even if you just talk about users as being one stakeholder category, most products don't have a user, they have multiple user classes who have different characteristics, needs, and different expectations. So it's very hard to make all stakeholders ecstatic with any single design. It's a real challenge. A third reason why design is hard is because a product exhibits many different quality characteristics. These are sometimes called design for attributes. In software, we usually call them quality attributes. So here's a list of some of the familiar design for attributes for software systems on the left, and there's a supplemental list for some other attribute categories for physical devices on the right. And many of those products might contain embedded software, so they get to deal with both sets of quality attributes. And the sad fact is, it's impossible to build a product that maximizes all of the desirable attributes. In addition, some of these attributes conflict with each other. Increasing one can decrease another. So designers need to know which of these quality attributes are most important for business success, so they can make the right design choices to achieve the best balance. And that's why an exploration of these quality attributes is a really important part of requirements development. So as I mentioned, the book presents 70 design lessons that I derived from observing both poorly and well-designed products. And these are the first 3 lessons, which I think are the most important. Maybe that's why I put them first. So first of all, we should focus design on usage, not on product features. I mentioned that before, and I'll probably mention it again because I think it's so important. Usage-centric design means understanding how people will use the product. Think about what people want to do with the product and the environment in which they'll be using it, then design the product to make it easy for users to get the job done. The second lesson is that design demands iteration. You're not going to get the design right on the first try. You have to iterate, approaching a better design with each cycle until you have a design that's good enough to satisfy the requirements. Now, if you're iterating on your design, how do you know what to change in the next cycle? Ideally, you'll have typical user representatives, real users when you can, work with a prototype or mock-up under realistic usage conditions. So users will give you insights when they touch the product that you just can't get in the design lab. Now, sometimes you have to work with user surrogates, but there's no substitute for having real users participate in the design process whenever possible. So now I'd like to look at my 9 design principles and see some product examples and some more design lessons. Now, the first design principle should hardly require stating. Let's make the product easy and obvious to use. So let me tell you about an experience I had recently. A couple of years ago, I rented a small SUV at an airport on a trip. Now, I don't have a lot of experience driving SUVs, and I could not, for the life of me, figure out how to open the tailgate to put my suitcase in the back. I spent 10 minutes groping around in this dimly lit garage for a latch, a handle, a button, a keyhole, anything, but I couldn't find it. So I looked at the key fob, because there's usually a button there to open up the trunk on a sedan or a hatch on a SUV. I couldn't find a button on the key fob. There was no button or lever anywhere inside the car to open the tailgate either. I was at a complete loss, and I finally had to ask the car rental people for assistance. Now, this is the back of the car, and the red circle on the right shows the door opening handle, which is right above the right taillight, and that looks very much like the non-functional chrome piece above the left taillight. Is that obvious to you? It certainly was not to me or to a friend of mine who's rented just coincidentally the exact same model of car and had the exact same problem I did. We simply couldn't find out how to open it. Now, it's interesting because once I did figure out how to open it, it only worked about half the time anyway. So this design was not only unobvious to use, not intuitive, but it didn't work very well either. So there's a lesson here, and that's that small design problems can interact to yield unexpectedly significant results. So having the combination of a disguised handle, no opener inside the car, and no button on the key fob, each of those was a small design choice, but putting them together made it impossible for me to figure out how to open the tailgate. And I've driven dozens and dozens of different rental cars in my long career as a consultant. So I thought I'd seen a lot of things, but this is totally new to me. So it would not have been much harder to provide the customer with multiple alternative opening mechanisms that people are used to in other cars. And this is the kind of problem that should have been discoverable during a prototype evaluation by real users who hadn't seen the car before. So you mock up something like this and you get some real users and you say, see if you can open the trunk, see how hard that is. And you see how long it takes for people to find that. And if it takes too long, especially under typical car rental conditions like in a garage, then there's a problem. So here's another example of unobvious design. Okay, this is the timer feature on my iPhone. The image on the left shows how the timer looks when it's counting down, in this case from 5 seconds. And the image on the right shows what the screen looks like after the timer countdown has reached 0. And incidentally, throughout the book, I have rarely identified the product or the manufacturer that I'm using as an example because it's not important. I mean, this is not a Consumer Reports article, so I'm not trying to provide a buyer's guide. I'm trying to learn from the design examples that we encounter. In a case like this, where people know what an iPhone looks like, it's kind of obvious and you're going to see what the product is. But in most cases, I haven't identified the product because it's not important. So a very smart friend of mine who has almost 50 years of software development experience used this timer function when several of us were playing a game one night. He set the timer for 30 seconds and the alarm sounded just like it was supposed to. However, it then took him 30 more seconds with help from the rest of us to try to figure out how do you turn the alarm off. It is totally unobvious. So if you look at that, there's a cancel button. Okay, well, we get to the right screen and the cancel button's still there. So maybe I tap on cancel. Nope, that doesn't do anything. Well, start's still there. Well, I thought we were done, but it says start. Okay, so I tap on start and that restarts the timer while the alarm is still sounding. And then the alarm goes off after it hits the end of the second countdown cycle. That makes no sense to me at all. So it turns out that what you actually do is to tap on the home button on the phone, or you tap at the gray bar at the top of this display. Now, how is the user supposed to know that that's how you turn it off? There's no clue. So a lesson from this app was that it's a bad idea to provide the user with options, like the cancel button shown there, that doesn't do anything, or that suggests they'll do something different from what they actually do. Software systems should present the user only with unambiguous and useful options. And you argue that, well, yeah, but cancel on the right is grayed out. Well, it's gray on the left also. It's just a little darker gray on the right. And if it doesn't do anything, why are you even showing it to me? I don't understand. So I don't think that's a very good design. Now we'll see some other examples from iPhones that I think are good designs, but that isn't one of them. All right, so another kind of situation we ran into here is, wait a minute, sorry. No, we're okay, sorry, I got a different count here. So it's also very important that we consider realistic usage scenarios. Somehow, it looks like, excuse me, a slight slide problem here. All right, no, here we go. All right, so last year I bought a, all right, I'm all set now. Sorry, I was a little confused on this end. Okay, so here's another example of a surprise. I don't think surprising behavior is very good in systems. And I saw a surprise in Excel. I'd made some changes in a workbook that was still open, and that caused the undo function to become active. So I created a new workbook, but I saw that the undo shortcut button was still active, as you can see in the red circle here, see at the top. But I hadn't done anything in that second workbook, so I don't know why it was set to undo. What exactly am I going to undo if I clicked on it? Well, of course, I clicked on it to see what happens. And here's what happened. Excel reversed my most recent operation from the first workbook. So the view switched back to that first workbook, but after it did the undo, so I couldn't tell what had happened. That was pretty confusing. Now, this is not how undo works in PowerPoint and Word. We expect that members of a product family like those in Microsoft Office will show some common behaviors from common functions. And of course, for the most part, they do, but they don't always. And the first lesson here was we should make sure the user won't be surprised by unexpected and undesired behavior. And the second lesson as well to use context to activate relevant functions. There's no point in having the undo be active if there was nothing to be undone in the present context, which in this case was a brand new workbook that I had opened. So it took me a while to figure that out, and I don't really appreciate software that wastes my time while I try to figure out just what the heck's going on. Okay, so that was our first design principle, to make things easy and obvious to use. Second principle is that we should consider realistic usage scenarios. Now, last year I bought a new wall oven, and I like it okay, but it has one absurd feature. Here's the control panel for the oven. And one of the things you want to do with a timer is with an oven is use the timer. So the oven does in fact have a timer that sounds an alarm when it counts down to 0. But that alarm is way too quiet. If you're standing more than a few feet away, you're not likely to hear it over normal background noise. And here's the thoughtfulness scale that kind of describes how this oven's alarm feature was designed, in my opinion. The nominal behavior is that the oven does in fact generate sound effects under appropriate conditions. Well, that's good. Now the designers thoughtfully allow the user to set the volume to one of 3 levels, also very considerate. However, the highest volume setting is still so quiet, so I think that fits into the thoughtless design category. And the lowest of the 3 volume settings is just comical. That's a new level of thoughtlessness. You have to stand right next to the oven to hear it, which defeats the whole purpose of having an alarm. So maybe this oven wasn't adequately tested in realistic home usage scenarios. My previous oven had a loud buzzer that I could hear anywhere around the house. This one sounds like the gentle tinkle of a distant ice cream truck. And sometimes, unless I'm paying careful attention, that sound barely penetrates my consciousness. It's kind of frustrating, and it seems like they could have done a better job. So you might be thinking, well, maybe your oven's just defective. So I actually called the manufacturer, and they somewhat sheepishly said, yeah, it's pretty quiet. That's how it's designed. So it's a design characteristic, not a problem with my particular unit or anything. Have you ever encountered, maybe in a cafeteria or restaurant, silverware like this that has smooth cylindrical handles? It's impossible to get a secure grip on them. The knife rolls into your hand if you're trying to cut a piece of meat or butter some bread. If you're eating cereal or soup with a spoon, be careful so you don't have it spin in your fingers and spill food in your lap. And it seems like it should be obvious, but I guess we have to say it, that products should be designed so people can use them effectively in a wide range of normal, realistic usage contexts. I can't imagine why someone would design such an everyday product as silverware in a way that simply doesn't work when you're trying to do something pretty ordinary like eating a meal. Our hands grip flattened and textured pieces of metal far more securely. This is the kind of design that just makes no sense to me at all, and yet you can find a variety of products like this available for sale. I remember the first time I found some of these in a restaurant or something. It's like, who came up with this idea? It seems like a pretty silly idea to me. So I do have many examples in the book of not so good iPhone designs, but also some very clever, I think, designs. And the Contacts app illustrates some aspects of thoughtful design. For instance, the input controls change depending on which field you're entering content into. In the email field here, the alphabetic keyboard pops up. Well, that makes sense, but I don't really understand why they included the emoticons and spacebar, as you can't put those characters in an email address. I'm guessing they're probably reusing a standard keyboard control there, and sometimes when you reuse a chunk of software, there's a little bit of compromise involved. So that's a small price to pay maybe. If you're entering content into a date field in the Contacts or in some other apps as well, Apple uses this rotary date entry control. I didn't show it here, but if you're entering a phone number, the numeric keyboard pops up with the special characters you might need, and the app attempts to format your entry into a standard North American phone number format until you enter too many digits and it decides that's not a North American phone number. So I consider this to be a thoughtful design, because using context like this to activate appropriate controls saves the user time and reduces errors. You can't put an invalid month in the date field if you can only choose from the 12 months of the year in the control they provide. I've seen controls in other applications that let users enter invalid dates like February 30th. That's not good because now there's going to be a problem somewhere that someone's going to have to correct. So the third principle is to consider a wide range of usage environments. Now, I rented a car in January a few years ago. Here's a photo of the climate control system. It has clearly labeled buttons and a reasonable layout, looks fine. However, I found that I kept hitting multiple buttons when I tried to adjust the control with gloves on. January, remember? The buttons were too small and close together in some cases to hit them precisely. So for example, if I press the rear defroster button here in the oval, I would also turn on the seat heater, the little button just to the left of it inside that red circle. So it was a little confusing. I'm driving along and I just turned on the defroster and then I felt the seat getting hotter and hotter. It's like, how'd that happen? So I found that it was a little touchy to control with these gloves. And now it's when you're manipulating the controls of an unfamiliar car while you're driving, maybe at night, that's hard enough. But when you get some unexpected outcome like this that you have to figure out while you're whizzing down the road, it's annoying to have to understand what's going on. So the lesson from this was that you should ensure that the design is usable and safe in a wide variety of likely operating environments and conditions. And this made me wonder if the designer of this climate control panel had somebody test the design while wearing gloves. I kind of doubt it. Doesn't seem like they would have come to that same design conclusion if they had. Now, if you're building a system that contains software that's going to be used in a variety of environments, there are some factors we ought to consider. Check how it works if it's under different lighting and weather conditions, if it's going to be outdoors. I've seen ATMs, for example, whose screens were nearly impossible to read at times because of screen glare from the sun. If the product involves audible input or output, like either, say, speech recognition or synthesized speech from a kiosk or maybe a supermarket self-checkout device, make sure the sound levels are appropriate for the intended operating environment. They're loud enough for the user to hear, but not so loud as to disturb others nearby. And I actually used a supermarket checkout machine a few days ago in a store where I basically could not hear exactly what the machine was saying to me. It was just too quiet for that environment. So you really have to test it in a range of environments to reach the sweet balance point. The fourth design principle is to make it hard to make a mistake. Now, here are some controls from my brother's pickup truck. The knob on the left controls the headlights. The identical knob on the right controls four-wheel drive. And my brother's a mechanical engineer, and he says that it's easy to reach down and grab the wrong knob by accident, which can lead to some startling results. Symmetry like this is nice for visual design, but maybe not so good for usability, especially by touch. So I think there are 4 ways a designer can consider how to deal with user mistakes, like grabbing the wrong knob and having something unexpected happen. The best option is to make it impossible for the user to make a mistake. Now, that's not always feasible. So a good alternative is to make it difficult for the user to make a mistake. Maybe the designer could have made the knobs different enough that a driver could tell by feel if they had the correct knob in hand. Now, maybe it wouldn't look quite so nice because the symmetrical design here then gets lost, but that's better than going down the road to switch on the lights and find yourself lurching into four-wheel drive all of a sudden. A third option is to make it as easy as possible for the user to recover from an error, either one of their own making or some system error that takes place. Now, the worst option is don't give it a thought, just let the mistake happen and force the user to deal with it. So the principle is that we want to make products easy to use correctly, but hard to use incorrectly. Let's see some more examples. One good design approach is to make it difficult for the user to take some destructive action by accident. This means making the options clear so the user isn't surprised when they take some action. This is the screen I see if I ask to delete a mailbox, which is just an email address and all the mail in it, at the control panel for my website. My hosting provider makes it perfectly clear what will happen if I choose this option. They give me the description here, and I need to take another step. I need to tick the checkbox to confirm that, yes, I understand and want to make the deletion, and only then does the grayed out button at the bottom to perform the delete action become active. Even better, after I delete the mailbox, I see another message saying that if I did this by mistake, I can recreate the address right on that same page, and the deleted mail will be automatically restored to it. My web hosting provider gives me a month to correct a mailbox that I might have deleted by mistake. I think that is very considerate, very thoughtful design. So I've been very happy with this kind of little thing that just protects you from yourself, protects you from quick mistakes. We've all clicked on the wrong button hastily, and it's nice to be able to not do too much damage when that happens. That little checkbox is kind of an extra step that makes you have to make sure you know what you're doing before you go too far. So here are some tips to help users avoid mistakes, some suggestions about how to design products to avoid mistakes in these 4 categories. Can we make things impossible? Maybe. With physical objects, designers sometimes use asymmetry to make sure the pieces fit together properly so you can't do it wrong. For example, there's only one way to connect a USB cable to a USB port. Unfortunately, you have to see both ends to be able to connect them properly, which is a big disadvantage. The USB-C and Apple Lightning plugs are symmetrical, so you can't get it wrong. That's actually the perfect solution. Now for software, let's not offer the user options that are illogical. The ATM at my former bank always asked me which account I wanted to use when I made a deposit or a withdrawal. It gave me 4 choices: primary or secondary, checking or savings. Guess how many accounts I had at the bank? That's right, I had 1 account. So it's just dumb to present the user with options of which 3/4 of them are logically impossible and make no sense and can only lead to errors. Now, sometimes we can make mistakes difficult with the help of software. We can provide controls and logic to constrain or correct or reformat user input instead of accepting bad user input and reporting an error and making the user fix it, like if they enter a phone number or a date. You know, there's no reason for the system to complain about a date because I used the wrong delimiters in the format, or I used parentheses instead of hyphens in the phone number or something. Just format it the way you want. Now, if an error happens anyway, the product should help the user correct it. Don't think of a problem report as being just an error message, but rather a guide to recovery. Now, if you're just going to let it happen, you don't need any tips from me. Just let the user deal with whatever the consequences are. I don't recommend that, incidentally. Now, I'm sure you've seen messages from computers that are just as helpful as the one this guy is holding. Those messages make me wonder, why are you telling me this? And what am I supposed to do with that information? So there are 7 characteristics that meaningful error messages and other system feedback should exhibit. It should be immediate. I'll say a little bit more about this later. The message should tell me something I don't know and need to know. It should be necessary. One website I use sometimes shows me that I have a notification when I log on. But when I click on the icon to access my notifications, all it says is, you have no notifications. Now that's an example of unnecessary and time-wasting feedback, just a complete waste. The messages need to be clear. I need to understand the point. Otherwise, why bother showing it to me? I'm sure you've seen messages where it wasn't clear what you're supposed to do next. It should be actionable, should help me know what to do next. Don't you hate messages that maybe flash by long enough for you to see that there was a message, but not long enough to read it and process it? Someone else decided how fast you read and think. Messages that aren't persistent are annoying. And messages should be polite. And in a moment, I'll show you an example of a polite message. But first, let's see some other feedback examples here. So I wanted to cancel a magazine subscription. And here's the dialog box I saw when I submitted my request. Now this message is ambiguous. It says, are you sure you want to cancel your subscription to Aerial Combat Magazine? And I've got the default ancient Windows prompts or options of OK and cancel, default being OK. But it's ambiguous. If I click on cancel, will it cancel my subscription like I'm requesting, or will it cancel out of this dialog? You'll notice that neither OK nor cancel is actually an answer to the question the box is posing to me either. So we can do better than that. Rather than using these traditional OK and cancel button labels, let's give buttons meaningful labels that logically answer the question the dialog box is asking. This way, the user knows exactly what's going to happen if I click on one button or another. Yes, cancel it. No, keep it. Also, the buttons don't have to look alike. You might design buttons that make it harder for the user to hit one by mistake that would be more destructive. A bigger green button for the safe option, a smaller red button for the riskier option. So if I saw those kinds of labels and buttons, the chance of me knowing what's going to happen when I click on one of them and clicking on the correct one, those chances go way up. I'm much less likely to make a mistake. We want to make the feedback actionable because it should provide to a user something that lets them know what to do next. Now, here's an error message that I often see after I make a backup from my PC to an external hard drive, and then I try to eject the drive. Windows can't stop your attached drive device because a program is still using it. Close any programs that might be using the device and then try again later. That is completely unhelpful. Windows clearly knows what programs are currently using the drive, but it doesn't tell me what they are, and it doesn't give me any way to turn them off. And in fact, with certain situations that I've used, certain applications, I have to shut down multiple other things that are running to try to be able to eject the drive properly. So all I can do at this point is just close the message box and try to figure it out on my own, which is frustrating and annoying. Now contrast this with a much more helpful message I get if I try to delete or rename or move a file that's open in an application. This is a nicely actionable message that tells me exactly what's going on and what to do about it. So again, don't think of this kind of feedback as error messages, but as guidance to help somebody solve a problem. Now here's an example of thoughtful design. I use Mozilla Thunderbird for email. Thunderbird looks for keywords that suggest you might have an attachment for an email you're writing. If it doesn't find one, and when you attempt to send it, you see this friendly reminder that says, oh, did you mean to add an attachment? Notice how the buttons are labeled in a way that answers the question so I know exactly what will result from each action. So I think this message hits all 7 of the desirable characteristics of feedback to the user. It's a heptafecta, 7-way winner. It's immediate, informative, necessary, and so forth. Wouldn't it be nice if all the messages we saw from computer systems and hardware devices were this helpful? I think that would be good. I don't like products that waste my time. Here's the home page for a financial services website I use. It's 100% content free. I don't know who that guy is or why I'm looking at him. The login fields are below the fold, meaning I have to scroll down to access them, or I can click on that tiny log on button that I've circled in red at the upper right. So maybe the company did some research and found that most of its visitors want to look at that guy with his cup of coffee and click on their promotional link, but I doubt it. I think most people who see this page just want to log into their account or look something up as efficiently as possible. You know, other time wasters include the currently fashionable website designs with huge fonts, meaningless images, and lots of white space that make the user scroll to get to anything you're interested in. I hate that. Sometimes I waste time trying to find the log out button on a website or a phone app. So cleverly concealed options like that suggest that the site owner really doesn't want you to log out, but that's my choice, so it shouldn't be that hard to do so. So the lesson here is that we want to let the user take as few actions as possible to perform a task. Now, in the interest of not wasting the user's time, the designer should also make it easy for users to access the tasks they perform most frequently. And a good way to decide how to lay out screens is to collect some data on how people use the application. An operational profile defines what percentage of the time users will perform various tasks, and that helps UX designers set defaults and priorities for screen layouts and menus to save time. So this financial services providers collected that kind of data on the frequency of different transfers and payments. And they put the one that's used most frequently at the top and even said it's the most used. And that is in fact the one that I use all the time. This layout saves me time. Now, avoiding one or two clicks or scrolls might not seem like much of a time savings, but multiply that times millions of users and many millions of sessions, and it's a lot of clicks and a lot of time saved. Too many application designers seem to regard the user's time as free. It is not. So one day I went shopping at two supermarkets. The cashier at one was friendly and efficient. And before I knew it, the receipt was in my hand. The cashier at the other store kept giving me instructions. I had to do things in a certain order. The cashier became impatient with me if I took too long to pull out my loyalty card or make payment. I forgot to mention that the first cashier was a pleasant young woman, and the cashier at the second store was this machine. I think it's hard to think of a product less thoughtfully designed for the user's convenience than a supermarket self-checkout station. Some are better than others, but a lot of times they're problematic. And the lesson here is that products should be designed to tolerate both technical faults and unexpected, imprecise human behavior. So a few other things that we can think of with regard to designing for the user's convenience is to let the user customize the experience whenever possible. That's a big help. Customization is a way to reach a good balance between ease of learning and ease of use, and to make a product usable by a wide range of customers. Another way to enhance the user's convenience is to let the computer do as much of the work as possible. So for example, have you ever typed in some long entry, like in a problem report, a big box on the screen, only to be told when you try to submit it that it's too long? That's not exactly immediate feedback. You don't know what the maximum length is. You don't know how much you'd have to take out. Now, if you have an input field with a character limit, don't make the user guess how many characters they can enter. Tell them how many and how many they have left, and then stop taking input when they reach the limit instead of showing them an error message later. Another good way to enhance the user's convenience with physical products is to design packaging that customers can open easily and safely. I just don't understand why we experience so many packaging failures. I have numerous examples in the book, and I'm sure you've had your own experiences with poorly designed packages. So why is this a problem? I mean, cardboard and plastic are not new technologies. Now, the word thoughtless could mean either showing a lack of thought or inconsiderate of others. And so far, we've seen examples of products that showed a lack of thought in their design, but some websites are deliberately inconsiderate of the users, and some are designed to be downright devious. Here's an example from the website of a bank that issued one of my 2 credit cards. When I go to pay my bill, the payment page doesn't show how much I owe. It only shows the minimum payment due of $25 in 3 places in these red boxes. I need to click on that little e-bills link in the red oval to find out how much I actually owe them this month. This website is clearly designed for the benefit of the business, not the consumer. They want me to pay just the minimum each month so they can charge me millions of dollars of interest. But the lesson here is to design for the benefit of the consumer over that of the business. So there's all sorts of so-called dark patterns like this, ranging from various subtle deceptions to downright fraud. You have to be careful to understand just what might happen if you click on some button. Now, it turns out that human characteristics span a very wide range of differences in multiple dimensions, and therefore my 8th design principle is that people should design products to accommodate the range of human variation. While it might not be possible to make every product equally usable by everybody, designers should respect the variations and be as inclusive as possible. And here are 2 examples of thoughtless design that don't account for some of that human variation. 2 of my friends reported the same problem. They're rather on the older side. They both live in condos in different retirement communities. They have furnace filters in their condos which need to be replaced periodically, but both of them told me that those furnace filters are installed at the top of a 12-foot high ceiling. Now, the condo designers knew that these were for older people, some with disabilities. Probably they don't all have great big ladders. So this is just inconsiderate design. Now, another friend works for a utility company. She creates maps of access roads for people who have to work on power transformers and the like. These roads are color-coded, but the people who define the mapping conventions, not my friend, chose colors that some colorblind drivers cannot distinguish. Now, color blindness is common, so any visual display needs to account for the possibility of users with color vision variations. So here are two thoughtfully designed products that accommodate some of that range of human variation. About 10% of the population is left-handed, but a lot of products are much easier for right-handed people to use. Now, these days, many computer mice are symmetrical, and the operating system lets the user configure the buttons to be logical for either left or right-handed people. So that increases their usability. In these fun days of COVID-19, most people have been wearing face masks, but those pose a communication barrier for people who are hearing impaired and read lips. Plus, they block a lot of the emotion that you see in one's face. So some companies have cleverly designed masks like this with clear plastic, so you can see the person behind the mask. I think that's both clever and considerate. So my final design principle is to place the minimum mental burden on the user. Now, here's the screen I see when I ask to log out from one website. Are you sure you want to log out? Any unsaved data will be lost. But that's a problem. The system knows if I've left any unsaved data during the session. It should only warn me about this if I really do have unsaved data. Otherwise, I just worry about it. If there is unsaved data, what data is it? And how do I get back to the right screen to fix the problem? This is an example of non-actionable user feedback. I don't know what I'm supposed to do, except get nervous that maybe I did something wrong and there's going to be a problem if I say, yes, log out. So the simple improvement of warning the user only when there really is unsaved data and then helping them to save it would completely solve the problem with this design. Another important lesson is to make functionality, as we saw earlier, that's shared by multiple members of a product family consistent. That enhances both ease of learning and ease of use, and it facilitates software reuse. As an example, in my iPhone, have you ever noticed how many different ways there are to delete objects on a phone? The prompts, the icons, and actions all vary depending on what kind of item you're deleting. Sometimes you need to confirm it, sometimes you don't. Sometimes you have to confirm deletion of a single object, but not a whole group of the same items. Now, which of those is more destructive? So it seems like the team that built each app decided to implement the delete function however they wanted to, which confuses users and raises their learning curve and error rate. Another inconsistency shows up in Microsoft Office. There's a lot of common behavior across the major apps, but there's enough inconsistencies to waste my time if I try to do something that works in one or two applications, but not in all of them. And here's a couple examples of shortcut keys that behave in one way in Word and PowerPoint, but do something completely different or nothing at all in Excel. So I'd like to wrap up here by summarizing several good practices that can lead to more thoughtful designs of any product. If you agree with my premise that usage-centered design is superior to product-centered design, then let's begin by understanding our stakeholders. Customers are a subset of stakeholders and user classes are subsets of customers. Now, during requirements development and design, you need to engage appropriate customer representatives of these various user classes so you can understand their needs and can validate solution ideas. I call these leading user class representatives product champions. They work with a requirements analyst or a BA or a product manager to bridge the gap between customers with needs and developers who craft solutions. So the product champion model I've found for many years works real well to help get more user engagement. Some good practices for thoughtful design include personas who serve as stand-ins for human beings when you don't have a real person to represent a particular user community. Prototyping is an excellent way to iteratively understand requirements and evolve designs. A prototype's a partial, preliminary, or possible solution to your problem. It's a lot easier for users to envision what a product might be like and how they'd use it from a tangible prototype instead of just a bunch of textual requirements and diagrams. So here's the cycle of steps you might go through when you're using prototypes. You develop some initial requirements and conceive a possible solution. You develop a prototype that you can have customers evaluate, and then everyone can refine based on that feedback, the problem statement and the requirements, and you can cycle back as many times as you need to. Now, even informal usability testing can reveal places where users are confused or make mistakes or take too many steps to get something done. The simplest approach is just watch people try to use your product or a prototype. Finally, every organization should learn from its previous experiences so it can do a better job even on the next time. Project retrospectives and collecting and analyzing customer feedback are good ways to continuously improve your designs. So if you take nothing else away from this presentation, please remember these three first lessons that I showed you. Focus design on usage, not on product features. Design demands iteration, and involve real users. Those three lessons alone can help you avoid creating many of the thoughtlessly designed products that drive us all nuts. So now let's go back to you, Tracy.
Thank you, Karl. That is a great presentation. We'd also like to thank Northwestern Data Science for sponsoring today's event. Northwestern Data Science and Analytics are an essential part of almost every industry today. You can build the high-level technical, analytical, and managerial skills needed for leadership roles in data science and Northwestern's online Masters in Data Science. You'll learn from top professionals in the field and position yourself for emerging career opportunities in a wide range of industries. Please visit www.sps.northwestern.edu/data. And with that, we're going to move into the question period. We don't have a lot of time, Karl. We've got a lot of great comments for you so far. I'm going to jump into the questions though. When should design requirements be captured? In advance by eliciting these requirements from the business stakeholders, or are these part of an iterative process where design requirements are discussed with the developer?
Well, I quibble a little bit with the phrase design requirements. I kind of like to separate requirements and design, but they do overlap a lot, and it should be an iterative process. Partly it boils down to in each project team determining who are the experts that can do a good job of design. You know, not every business analyst, not every user is a UX expert or somebody who's got experience designing user interfaces. They might have ideas, but and we should collect those ideas, but I like to make sure we have the right people with the right skills optimizing the designs rather than just coming up with a design. So I guess my answer is kind of all of the above. Let's collect input from various people as we go along, but except for true constraints, let's not paint ourselves into design corners prematurely. Let's have the right people who can do a better job of that, take the input from the other people, distinguish real constraints we have to respect from just solution ideas, and then let's iterate to get feedback on the solutions we come up with and the prototypes that we design to make sure that we converge towards something that people agree is the best way we can do it.
Thanks, Karl. Our next question. So how would you recommend this? Is it system behaviors or response when it comes to privacy or security?
I don't really understand the question.
Sorry, let me just repeat that. And so what would your recommendations be about system behaviors or response when it comes to privacy or security?
Well, that's a really large topic. I mean, I'm in favor of privacy and security. Both of those are very important. And I think this is a case where you need to understand, you need to explore the privacy and security requirements during the rest of requirements exploration discussions. That's something you don't want to paste on at the end, because we all cope with endless updates of systems and browsers and everything to close security holes. So if we can do some upfront thinking to understand privacy constraints, who can access what kind of data through appropriate business rules, all of that stuff has to feed into it as part of requirements exploration, so we can design for security rather than trying to glue security or privacy on after we've built a product and find out that people aren't happy with how their information is being accessed or exposed. But I mean, there's no short answer to that particular question other than, yeah, privacy and security are really important. Start talking about them early and design it in.
Thank you, Karl. Our next question and a comment, outstanding presentation. And I work in analytics and follow visual recommendations from Stephen Few and other experts. Are there any specific suggestions or recommendations, resources for interacting with data?
I don't really know. I mean, pretty much every system involves interacting with data in some form. So basically, good user interface design can cover a lot of things. But if you're talking about specific analytics kind of things where you have to design dashboards or provide querying capabilities for people to view the data in different ways. I would suggest looking at two resources that are kind of experts for visual design and user experience design in general. One is a book called About Face by Alan Cooper and others. The book About Face, I think 4th edition now, is a classic. Also, the Nielsen-Norman Group brings together the best of wisdom from two of the real leaders in user experience design, Jakob Nielsen and Don Norman. So those would be great resources to try to find out if there's any specific guidance for analytics kinds of interactions.
Thanks, Karl. Now, at what stages of the product design should teams focus their attention on these best practices?
I would say day one, maybe day two would be a good place to start. Like I said, these things are not things you want to glue on. They're things they're practices you want to incorporate into your process. So it's just part of how you approach system design. For example, stakeholder analysis is a very good place to start early on projects, and you want to identify user classes, and from that then identify who can be the literal voice of the customer, who could be a product champion to best represent the needs of a particular user class. And you want to do that very early so you can begin engaging with those kinds of user representatives from the beginning. We have found that was just a tremendously valuable improvement in our software development approach when I was working at Kodak. So I think this has to be just a core set of practices that you incorporate into your process. Now, what you want to avoid, though, is starting to put the cart ahead of the horse and start on design on day one. I'm not talking about designing on day one. I'm talking about understanding the problem and conceiving solutions beginning on day one. That drives the design, but there's this iteration. There's not a real sharp black line between requirements and design. There's kind of this gray fuzzy area where during requirements explorations, taking some tentative steps into design by sketching out even simple screen prototypes can be very valuable. But I would view these not so much as just steps in a process, but part of the culture that you adopt as you approach system development.
Thanks, Karl. And I have time for just one more question, or really it's more of a comment if you have any thoughts for this, but some might say that what you call thoughtless might be for people who like form over function. For example, think of tableware. For example, it's a fine line, and I prefer obvious function over form. Do you have any comments on that, Karl?
I agree completely with every aspect of that comment. I too favor function over form. I don't have a super strong aesthetic sense, and I don't really care how pretty something is if I can't do what I need to do with it, or if it makes it harder for me to do what I need to do. It is a balance point because products have to differentiate themselves from competing products in the marketplace. Products need to look appealing. You don't want to end up interacting with something that looks offensive or repellent to you. But a lot of the fashion stuff I find to be just time wasting. Like I mentioned, these common website designs now where you have giant text and giant stock images of people that convey no useful information, and you have to look all over the place to try to find what it is you're trying to do. Those kinds of things annoy me. My website hosting provider, the company called Tiger Technologies, their websites are pretty basic, pretty simple, and they're efficient, and they're fast, and they work well, and they provide me with all the capabilities I need, and that's fine. If I want to look at pretty pictures, I can look in a magazine or something. So I too favor function over form, but it's a balance.
And thank you, Karl. That is all the time that we have for today. So we would like to thank you for such a great presentation today. And we'd also like to thank Northwestern for sponsoring today's event. And again, we'd like to thank everyone for attending today's Modern Analyst webinar. And I'd like to remind everyone that today's webinar, along with the slides, will be archived at ModernAnalyst.com within a few business days. Karl, again, thanks for such a great presentation.
My pleasure.
This concludes today's event. We hope everyone has a great day.
Bye. Thanks for joining us.